till now we have discussed how to calculate these important parameters, namely the 95th percentile and the geometric mean and geometric standard deviation. And very frequently, when you are practicing industrial hygiene and you are in the field, you may want to just eyeball the data. And a number of studies have shown that industrial hygienists are not particularly good at eyeballing data. And what I'm going to give you are a few simple rules of thumb that might make you better at it. The purpose of this rule of thumb for eyeballing data is to quickly estimate where the true 95th percentile might lie. If you remember, the geometric mean that you calculate is very close to the median of the log normal distribution. In fact, for a log normal distribution, the geometric mean is the median. And the other thing you will remember from our discussion of log normal statistics is that any kind of percentile is given by the second equation on this slide. So, for example, if we are interested in the 95th percentile, x95, that is equal to GM times GST raised to the power 1.645, which is the z statistic corresponding to the 95th percentile. If you wanted to look at some other percentile, you would use a different z statistic. And so this simple formula can be used to estimate the 95th percentile. So in this slide, at the top, I again show the equation, the GM times GST raised to the power some z statistic, and for the 95th percentile, the z statistic is 1.645. What I'm showing in this table are estimates of the 95th percentile for a variety of values of the geometric standard deviation. And these geometric standard deviations span the range of commonly observed geometric standard deviations in workplaces. So it is very rare that you would see a GST greater than 3 in most workplaces. And likewise, it is also rare that GSTs less than 1.5 are observed. So this is, in fact, a commonly observed range of GSTs in most workplaces. This table is presenting, in the yellow highlighted part, the 95th percentile as a multiple of the geometric mean, or the median. So if the GST is 1.5, then the 95th percentile is 1.95. If the GST is 2.0, then the 95th percentile is 3.13, and so on. We can break down this table as if you have a low GST, and by low I mean around 1.5, then the 95th percentile is around 2 or 2 times the geometric mean or the median. And now on the other end, if you have a high GST, the GST of 3 in this case, then the 95th percentile is 6 times the geometric mean. And in the middle, you can split the difference between 3.13 and 4.5 and call it 4. So if you have a moderate GST, somewhere in the 2 to 2.5 range, then the 95th percentile is 4 times the geometric mean or the median. So the rule of thumb, I call it the 2, 4, and 6 rule of thumb. So for a low GST, the 95th percentile is 2 times the geometric mean. For a moderate GST, the 95th percentile is 4 times the geometric mean. And for a high GST, the 95th percentile is 6 times the geometric mean. And so that is shown in this slide. So 2, 4, and 6, this is what we need to remember. Now, how do we calculate? So the rule of thumb multiplier is, as I just said, for a low variability workplace or work scenario or SEG, you multiply the geometric mean by 2. For a medium variability scenario or SEG, you multiply the geometric mean by 4. And for a high variability SEG, you multiply the geometric mean by 6. So let's revisit all our rules of thumb. And there are a couple additional rules of thumb I've added on this slide. So if we have a small number of measurements, and by that I mean less than 6, and if even one measurement is greater than the occupational exposure limit, then you can straight away decide that the exposures are in category 4 of the AIHA categories, meaning that the 95th percentile is going to exceed the exposure limit. If we don't have that kind of a straightforward, easy data set, then we have to estimate the median and then use it as a surrogate for the sample geometric mean. And we all know from our early statistics courses how to estimate a median. So we will sort the data, and if n, the number of measurements, is odd, then the median is the middle value. And if n is even, then the median is the average of the two middle values. So calculating a median from a small data set is very straightforward and almost trivial. And you will use that number that you calculate as your estimate of the geometric mean. And then you multiply this value, the median, by 2, 4, and 6, and these would comprise an approximate low, middle, and high estimate of the 95th percentile. If you think that your data have very little spread, that means it's a low variability setting, and then you would focus on the 2 times the median, and that would be a good estimate of the 95th percentile. If your data have a large spread, then you would emphasize on the 6 times median as an estimate of the 95th percentile. So let's look at this following data set and see how our rules of thumb work. I had, in fact, given you this data set towards the beginning of my lecture and asked you to provide your judgment of whether the data set represented an acceptable scenario or an unacceptable scenario. We are going to revisit this armed with our new knowledge about how to estimate 95th percentiles. So the first data set, if you recall, it has only 2 data points, 21 and 68. And so the median is just, in fact, the average of those 2 data points. So the median is 45. And so 2, 4, and 6 times the median or the geometric mean correspond to 90, 180, and 270. And we have an occupational exposure limit, which is for xylene, which is the threshold limit value, or TLV, of 100 parts per million. And so if 2 of these values, 180 and 270, exceed the exposure limit, and since we have only 2 data points and they seem somewhat far apart, we can consider the moderate to high variability as possibly representing this scenario. And therefore, we can conclude that the data set most likely comes from an unacceptable exposure scenario, because the 95th percentile, 180 or 270, they both exceed the exposure limit. The second scenario, we have 5 data points, and one of them exceeds the exposure limit, 109. And so we can automatically conclude that this is an unacceptable scenario, and the 95th percentile is most likely going to be above the exposure limit. The third scenario is we have 4 data points, and you can see 12, 16, 21, and 24. They're fairly tightly clustered. So we can calculate the median as the average of the 2 middle points, which is 16 and 21. And so that comes out to be 19. And you multiply 19 by 2, 4, and 6. So you get 38, 76, and 114. And since we consider this to be fairly tightly clustered data set, the variability is low or possibly moderate, and therefore the 95th percentile is less than the exposure limit. So it could be either 38 or 76, but probably not 114. And so we would consider this, again, an acceptable scenario. The 95th percentile does not exceed the exposure limit. In the fourth data set, we have only 1 data point, 5, and so the median is just 5. And if you multiply it by 2, 4, and 6, at most we get a value of 30, even if it's a highly variable setting. And so we can conclude that this most likely is an acceptable exposure scenario. Although you may still have some misgivings because you're basing your judgment on just 1 data point. And you may decide that maybe a few more data points might need to be collected. In the fifth data set, again, we have 5 data points. The lowest is 5, the highest is 70, and the median value is 12. And so multiplying it by 2, 4, and 6, you get 24, 48, and 72. And so again, this is a fairly tightly distributed data set, and the 95th percentile, even in the most variable scenario, is only 72, and it's well below the exposure limit. So we would consider this an acceptable exposure scenario, in whether it's even if it's highly variable. We have discussed a variety of calculations in the past lecture for different exposure parameters. Now I'm going to show you an Excel spreadsheet that does all these calculations for you. And the name of this spreadsheet is called the IH Stat Excel spreadsheet, and it is available to you in the online library.